often referred to as nodes, that is computer systems, connected by communication links. A node can be a computer, printer, or any other device capable of sending or receiving data generated by other nodes on the network. Distributed processing. Most networks use distributed processing, in which a task is divided among multiple computers. Instead of one single large machine being responsible for all aspects of a process, separate computers can handle subset. Network criteria. What are the basic criteria that affect the network? A network must be able to meet a certain number of criteria. The most important of these are performance, reliability, and security. Performance can be measured in many ways, including transit time and response time. Transit time is the amount of time required to travel from one device to another. Response time is the elapsed time between an inquiry and response. Performance is evaluated by two networking matrices, throughput and delay. Throughput is otherwise called as bandwidth. Reliability is measured by the frequency of failure, the time it takes a link to recover from failure. Security. It includes protecting data from unauthorized access, protecting data from damage and development, and implementing policies and procedures for recovery from breaches and data loss. These are the three main criteria involved in network. The network depends on these three important criteria: performance, reliability, security. Performance is determined by the two important matrices, throughput and delay. Next topic: what are the different types of connections available in networks? A network is two or more devices connected through links. A link is a communications pathway that transfers data from one device to another. There are two possible types of connection. One is point to point, another one is multi-point. What do you mean by point to point? A point to point connection provides a dedicated link between two devices. The entire capacity of the link is reserved for transmission between those two devices. When you exchange, example for point to point communication, when you exchange television channels by infrared remote control, you are establishing a point to point connection between the remote control and the television's control system. No other device or anyone can interrupt with communication between the infrared and the television. What do you mean by multi-point? A multi-point connection, also called as multi-drop, is one in which more than two specific devices share a single link. The figure 3 shows the two basic type of communications: point to point and multi-point. Figure A shows the point to point communication between two stations. Here only two stations share a common link. Figure B shows the multi-point communication in which one mainframe and three other stations can share a single link. Topologies. Next topic is topologies. What are the different types of network topologies? We are going to see what are the different types of network topologies and their advantages and disadvantages. Topology of a network is the geometric representation of the relationship of all the links and linking devices to one another. There are four basic topologies are available. One is mesh, star, bus and ring. Mesh, star, bus and ring. The first one is mesh topology. Mesh topology is otherwise called as fully connected mesh topology. Here 5 devices are shown: station 1, station 2, station 3, station 4, station 5. Station 1 connected to all other remaining 4 stations: station 2, station 4, station 3, station 5, and same to station 2. Station 2 also connected to all other remaining 4 stations: station 1, station 4, station 5, station 3. In a mesh topology, every device has a dedicated point-to-point link to every other device. The term dedicated means that the link carries traffic only between the two devices it connects. To find the number of physical links in a fully connected mesh network with n nodes, node 1 must be connected to n-1 nodes, and node 2 must be connected to n-1 nodes, and finally node n must be connected to n-1 nodes. Thus, n into n-1 links are needed. However, if each physical link allows communication in both directions, duplex mode, we can divide the number of links by 2. Therefore, in mesh topology, n into n-1 by 2 duplex mode links. What are the advantages of mesh topology? The use of dedicated links guarantees that each connection can carry its own data load, thus eliminating the traffic problems that can occur when links must be shared by multiple devices. Mesh topology is robust in the sense, if one link becomes unusable, it does not incapacitate the entire system. Right? So, for example, if the communication between the station 1 and station 2, if it is failed, then station 1 can communicate with station 2 through station 4. Right? Similarly, if the communication between the station 2 and station 3 is failed, then station 2 can communicate with station 3 through station 4. Yes, okay, through station 4. Right? Privacy or security due to dedicated link. Point-to-point links make fault identification and fault isolation easy. Traffic can be routed to avoid links with suspected problems. What are the disadvantages of mesh topology? Amount of cabling, right? For example, if station 1 in this previous figure in mesh topology, 5 stations are interconnected. Station 1 it should be connected separately to all other remaining 4 stations. Similarly, station 2 it also connected to all other remaining 4 stations. So, amount of cabling and the number of I/O ports required, because in the above example 5 stations are interconnected. If one station want to be connected to all other remaining 4 stations, it should have 4 ports and 4 cables, separate cables. Bulk of wiring can be greater than available space. The hardware required to connect each link can be prohibitively expensive.